Okay, today I'm going to be talking about radian angle measure. This is Mr. Hunt here. Degrees and radians are the two ways that we measure an angle. If you're following along in the packet, this will be page 13 to 14. And we'll also be at that website. You can go ahead and click on that or go to that website, mathisfun.com/geometry/radians. So go ahead and get to that website and turn to packet, page 13 to 14. Basically, I'm going to explain a lot of what's going on page 13, what I say in words there. We measure length in a lot of different ways: centimeters, inches, miles, meters. We measure liquid in milliliters and liters and gallons and ounces. Okay, I'm not going to write all those down, but there's many different ways we measure, right? Different units. Same for degree, same for angles. So far, all you've ever really done is degrees, but it's also going to be important moving forward to do radian angle measure, just a different way to measure an angle. I will still make sure on your calculator, when we were doing the trig unit, and we said make sure you're in degrees. Well, that doesn't change here, okay? You can still be in degree mode. You don't have to change it if you have your graphing calculator or even a scientific. If you change the mode to radian, you don't need to do that, okay? We're still in degree mode. But we're going to talk a little bit about what radians are. First thing I'd like for us to do is walk through this example below. And what we're going to do is we're going to find the ratio of arc length to the radius in each of these two circles. What we're going to illustrate is since all circles are similar, we're going to find an interesting pattern about the ratio here. And I mean, just think about that, right? If we have a circle with a radius of 2, and we have a circle with a radius of 5, and a circle with a radius of 7, these all are going to be similar, right? All we have to do is multiply, well, I should have used maybe 6 here. Multiply the radius here by 3 in this first circle to get to the second one, right? Dilate by 3. Okay, all of them are similar, a similarity transformation. So let's do that example below. The first circle has a radius of 5, and they both have a central angle of 60. Okay, the second one has a radius of 8, and again, a central angle of 60. And we can, again, as always, just transfer that angle, that central angle, same. Central angles are the same as to the arc. So they want us in each one to find the arc length. Well, the first one, we know how to do arc length. It's the measure of the arc over 360 times the circumference times 2 pi r, in this case 5. Over here, oh, by the way, arc length is sometimes abbreviated as lowercase s, and that's what I did here. If you want to put AL, arc length, that's fine, but lowercase s. So in this circle, same thing, 60 over 360 times 2 pi, but 8. Okay, so if I enter these in, 60 over 360 times 2 times 5, I'm going to leave the pi out, I would get 1.6 repeating pi. 1.67. You should do these as well, right? Try these out in your calculator. 60 over 360 times 2 times 8 over here. 2.6 repeating pi. 2.66. So on. So let's do an interesting thing here. Let's compare the ratio of the arc length over the radius. So if I do this one, it's arc length over the radius of 5, and if I go over here, 2.6 repeating pi over 8. Okay, so go ahead and put that in your calculator. And what you should find, do it, pause the video here, try it out. What you should find is that each of them is equal to 1/3. Okay, they're both 0.3 repeating. They're each equal to 1/3. So what that shows us is it doesn't matter how big the circle is if we're using the same angle measure there in the middle, because all circles are similar, really the ratio of the arc length over the radius is going to be constant. So we can create a new way to measure angles, and we call it radian. Okay, a radian measure. And I say below this example, it gives rise to a definition of radians. And a radian is simply that box below. A radian rotation of arc length s about a circle whose radius is r is simply given by s over r, the arc length divided by the radius. You'd think it depends on the size of the circle, but what we just showed in the last one, it doesn't. All circles are similar. Right? If you have a small, let's go back. Yeah, that's bad. Small circle, bigger circle, this, that we started with. Well, if you still take the 60 degrees, so we had that 60, and this was 2, and this was like 6 for a radius, but still 60. This is like 8, still 60. Well, if you do the arc length here to the radius, and the arc length to the radius, and the arc length to the radius, if you do that ratio, it's all going to be the same angle. It's going to be the same measure. Okay, so that's what ends up happening, because all circles are similar. That ratio is going to be equal, and we define it as a radian measure. Here's what I want you to do now. Go to mathisfun.com, go to that website, and I just want you to look at a couple examples there. It talks about what radians are first. There's the length and the radius, and comparing it, and they tell you what 1 radian, how many degrees it is about. I want you to just go just slightly down where it says the radian is a pure measure based on the radius of the circle, and there's a little button there that you can click, that's the play button, and it just nicely illustrates it. It shows this. Here, let's see how it starts again. It starts with just the radius there, and it takes, it's really cool how it does it. Play it again. It takes that radius and it puts it out to the side here, and then it wraps it around, and it wraps it around there, around the arc. And they give you another nice definition of radian right below it. It says, radian, the angle made when we take the radius and wrap it round the circle. And that's really what it is. Okay, we take this radius length and we wrap it around the circle, and we measure how far in degrees, not in degrees, in radians, how far we went. That's the angle, how far that radius took us. And because all circles are similar, it's 1 radian is always going to be the same amount. It's always going to be about that far. Now, I want you to just do one other thing for me. Go down right below that, and you're going to click play on this next one. It says radians and degrees. Let us see why 1 radian is equal to 57.2958 degrees. Just hit play there. And what this one is really interesting, and this is one of the most important reasons why we do radians. You take that 1 radian, which is about here, right? That's 1 radian. You do another one. There's another radian, so that's 2. You do another radian. There's 3. And then you have a little bit left over here. And what's amazing is that halfway around the circle, which we like to think of as 180 degrees, is equivalent to 3.14159 ... radians. You should recognize that as pi. So, one of the most important things, and why this is important, 3.14 pi radians is 180 degrees, and we can get so many other relationships based off of that. Okay, feel free to scroll through that page and look through some other things on there. So take a couple minutes to do that. Just look at that website with radians. I'm going to go ahead and move on. So page 14, and here's what I say. I'm glad I explained what a radian is. I want you to know it, but the air test essentially wants you to know how to do conversion, how to go from degrees to radians and radians to degrees. All right, it's like going from centimeters to inches. They want you to know how to convert. And I give you a nice little table there. The Math is Fun website also illustrates it a little bit. But to go from degrees to radians, you're going to multiply whatever degrees you have by pi over 180. And it's just the reverse, reciprocal. To go from radians to degrees, you're going to multiply by 180 over pi. So let's do a few real quick. I'll put A down here. One complete rotation is the same as how many radians? Well, one complete rotation we know is 360 degrees. So they wanted to know, well, how many radians is that? So I'm looking at the top one, degrees to radians, simply multiply by pi over 180. Now I will be more clear on like a test or quiz, like, and I'm sure the air test will too. Leave it in decimals or leave it in pi form. This one, let's leave in pi form. So I'll leave the pi in there, and the reason is because what happens here, 360 divided by the 180 is 2. So we get 2 pi. Is that hopefully not too surprising, because halfway around on the last page we just discussed was pi. So a full circle, it's double that, it's 2 pi. All right, let's do B. 1 radian, you can write RAD is abbreviation for radian if you'd like. 1 radian is the same as how many degrees? How many degrees? Well, this is going back to the second one there, and the box, to get radians to degrees multiplied by 180 over pi. Now, I actually didn't mean to say pi form for this one. I'd like for us to do a decimal form. And what we see, try it out in your calculator, pause the video, 57.295, it keeps going, degrees. And guys, again, on the website, they show that. So if you looked and said, okay, 1 radian is this amount, well, 57.296 degrees. So remember, that's the ratio of the arc length over the radius for any circle. Any circle. All right, so the last two real quick here. Let's finish up. So C, convert 30 degrees to radians. So that's times pi over 180. Let's leave this in pi form. 30 over 180. 30 over 180. It's 1/6. Another way that you'll see this one, this is a key value coming up in the future, you'll just write it as pi over 6. Right? The 1 is implied up top there with the pi. So pi over 6, or 1/6 pi. Again, this is going to be the way you're going to write it in the future. That's a key value there, pi over 6. All right, and last one. 30 radians to degrees. Now think about this one, 30 radians to degrees. Well, 1 radian was 57 some degrees, so this is going to be a lot. Multiply by 180 over pi. Okay, so 30 times 180 is really 5,400 divided by pi. That would be the answer if they said in pi form. Let's go ahead and do it in decimal form as well. So it's about 1,718.9, we'll round to degrees. Now you might say, how can you go above 360 there? Well, we think of this as 360 would be 1 rotation, go again 720, 1080, right? And you keep going around the circle. So this is actually equivalent to a degree between 0 and 360, but we don't go that far. Okay, this is Mr. Hunt here with Radian Angle Measure. Thanks for watching.